engine repair 2, okay?
Engine repair test 2.
Yep. Convection heat transfer occurs when heat is transferred from one object to another by direct
What's
contact.
convection?
Convection. Somebody tell me. Anybody know?
Convection is when the air around something, or the air in the area is hot and it heats up something. It spreads through it. Heat spreading through air.
That's what convection means?
It conveys, yeah.
So
Yeah.
it's
Well, actually, so what that answer is actually going to be a falsie.
Yeah.
False.
When you say that,
False.
am I right about that?
So both 1 and 2 is false.
Yeah. Now that's a conduction heat transfer occurs when an object is heated as a result of heat in the surrounding area. Those two are actually reversed.
Yep.
Convection. Think about conveying the heat. Conduction is when two objects are touching each other.
Yeah.
And all that. You remember what I told you about the refrigerant when you get out of the bathtub or the shower or the pool or whatever, and there's a little wind blowing, and you say, "Man, it's cold. I got to wrap myself up with a towel." That's because the evaporation of that refrigerant, which is the water in this case, is carrying the heat away from your skin. Now, alcohol does that. Alcohol is a better refrigerant. You know how you put your hand in alcohol and let it out, it gets real cold?
Yeah.
But what about the fluids that go the other way? Can you think of anything that's designed to have a really high boiling point?
Antifreeze.
It's antifreeze. You put antifreeze on your hand, it's going to feel warm. You put alcohol on your hand, it's going to feel cold, right?
Yeah.
You put brake fluid on your hand, it feels
hot.
warm. See what I'm saying?
So that's not because the brake fluid?
It's actually because of the properties of the brake fluid.
So
I would submit that the alcohol evaporates really fast, and so it's going to take heat out of whatever it's touching as it evaporates.
So that's what I'm saying. Brake fluid is not literally the brake fluid burning you. It's the brake fluid holding the heat into you.
Yeah, it's actually the properties of the brake fluid's got to have a high boiling point, and so does antifreeze. Is that what I'm saying?
Yeah.
However, if you put pure antifreeze in your cooling system, it can turn to jelly at like 8 below zero, and it causes you to burn the motor up. And it doesn't protect as well as a mixture, water antifreeze.
Acetone evaporates real easy.
Huh?
Acetone, it evaporates real easy.
Mm-hmm. It does. Methyl ethyl ketone and all that stuff. But you've also got, and acetone is really to finish on your furniture too, and it'll also take fingernail polish off and all that. I tell you something else too. I mentioned this I think last semester. There was a time I went through this spell where I had these bad hiccups. Lasted about 4 days. And when I was sleeping at night, I didn't hiccup. But when I was, if I drank something cold, I'd get a hiccup real bad. I mean, real hiccups. I mean, big hurting hiccups. And it eventually went away. But they had, my wife told me, she said, "Go up there and get some of this gripe water stuff from Walgreens." And when I did, and when I put it in my mouth, I said, "That tastes like antifreeze." And I turned it over, and it was made out of ethylene glycol. It was actually antifreeze. And this little thing, and they were supposed to give it to babies so they wouldn't hiccup. What's that going to do to your kidneys, man? Okay. And they said, I'm serious. I mean, this is some of that stuff. And I saw propylene glycol laxative they had up there. And that's like the orange antifreeze. They're putting that in medicine and you're supposed to eat. Good grief.
Yeah, I don't trust
People that don't know what that, yeah. All right. Most radiators, are the downflow type.
What does that mean?
Well, think about the way the flues are. Are the flues going up and down, or are the flues going back and forth?
Down. Okay.
Okay. Well, the ones nowadays, though, what are they?
I don't know, for real. And then look.
Well, think about the radiator in the cars that you're familiar with. Do the flues go sideways or do they go up and down?
They go sideways.
Now they're not saying all, they're saying most. Right?
Mine go up and down.
Yours go up and down. Okay, so what about yours, Chelsea? You know
I
where
have
they
no
go?
idea because I don't have a vehicle.
Yeah. If you look at if you look down in your radiator cap, where's the radiator cap and where are the tanks? That's what you need to think about.
Tanks are usually up here on the side, on the left side up top.
If it's on the side, they're going to be going crossways. If it's right in the middle on the top, they're going up and down.
Mine's going up and down.
There you go. See what I'm saying?
So most
That
of
ain't
them-
complicated, is it?
So most of them are up and down, man.
Also, you can look at the radiator and tell if they're going up and down or sideways.
Yeah.
So that's not. And I've got an entire article that I wrote on heat exchangers. Well, I've written 2 or 3 of them. I wrote one for Motor Age, I wrote one for Mobile Air Conditioning Society. And I'm going to see if I can print those out and give them to you. I can do.
Intercoolers are sideways.
Huh?
So my intercoolers are sideways.
Yeah, that's not a bad thing either. And think about the.
So
Now let me ask you this: your oil cooler that you guys are changing in the Saturn out there, Okay, yeah, now does it, how is it gonna transfer heat from the oil to the coolant?
Contact.
Convection or conduction?
Convection.
Okay, convection is a good answer, but where does the heat go?
Heat goes from hot to cold.
Well, it does, but what I mean is it goes into the coolant, and the coolant is pumped to the radiator, right? So these things are intertwined, convection and conduction. So the coolant is pumped by the water pump through there, takes the water out of the engine and out of the oil cooler, and then it goes out here to the radiator, and the air blowing across these flues in the radiator are what's going to cause your heat to go away. So it's actually, you're actually carrying the heat in the water out there so that it can, by convection. Well, now let me ask you this: what about heat that's by radiation? I'm not talking about nuclear radiation, but I'm talking about radiated heat. Would be like what? Ever stood under one of the infrared heaters in the shop and said, "Crap, that thing's hot. I need to turn it off." You ever do that?
Convection.
Or you're standing out in the hot sun. That's radiated heat, right?
That's conduction.
Yeah. Well, no, it's actually radiated.
Huh?
It's radiate. I mean, that's a different kind. That's another category beyond conduction and convection is radiant heat. A fan drive clutch is controlled by the temperature of the air moving through the radiator. True or false? A fan drive clutch is controlled by the temperature of the air moving through the radiator. That's number 4. Is that true or false?
False.
Come on. Where are you going?
What was number 3?
True.
This is a fan drive clutch.
Here he comes.
This is what we're talking about. This is a fan drive clutch. And you notice that, see the fan, and I mean, they're coming through the radiator, but it's hitting this, right? You notice all these fins on it? You see that? Okay, you notice it also is sort of like a viscous clutch. I can hold the fan still. This is where the fan bolts. I can hold it still. Now look at this little strip right here. All right, if I were to take a torch,
Yeah, heat it up and it engages.
and actually you heat it up and that actually moves. And it's moving something inside here. And whenever it moves something, this is a bimetal strip. And a bimetal strip means you got 2 pieces of metal married together that are different, that expand at different rates. Okay, now you can heat this with a torch and you can watch it change shapes. It goes back in your old air conditioner thermostats had a spiral spring in them. And as they heated up, because they were bimetal, they would change shape and it would move these mercury switches. It would cause them to go. On your choke, on your carburetor, it's got a bimetal spiral spring in there. As it heats up, the choke opens up because it's hooked to the little choke lever. This right here, that one's not in a coil, but it's going to move. This one's bad. That's when we changed it out. And it wasn't locked up. They can lock up and be bad too. And when they lock up and be bad, they sound like an airplane taking off, and they take rob a lot of your engine power. We don't want this fan to be robbing engine power, so we let it freewheel unless enough heat comes through the radiator to engage this viscous coupling and cause that fan to actually spin closer to the speed of this thing here.
No, I know that.
Yeah, that's exactly how that works. The air coming through the radiator changes the shape of this thing. If it gets really, really hot coming through the radiator, this engages that and the fan turns faster. You got it?
That's true.
Actually, I said this hooks to the fan. I was being stupid. That hooks to the water pump. This right here is where the fan bolts on. I don't know why I said that earlier.
You
but-
would have been stupid. You just got it.
Yeah, I just got messed up, and somebody glued a penny to this. Why did they do that? Anyway, that is crazy. Look at that. Somebody took some gorilla snot and put a penny to it. Anyway, that right there is a fan clutch. These cost about $100. There also are some, and I got one over there somewhere, that is controlled electrically by the PCM.
Fan?
Yep. This fan clutch here, don't let this stuff fall off. Don't. This fan clutch right here is controlled. It's a fan clutch that's electrically controlled by the PCM. This came off of a Trailblazer, right? And what it was doing is it was blowing too fast, making noise. Also, what I couldn't do was change the speed of it with a scan tool.
Why?
Because it was a bad one. And these things go bad, you know, and they may cause symptoms and stuff. So anyway, that particular one there was replaced for that reason. And this is actually plugged into some wires up here, you know, which seem pretty dicey. You think it's going to get wrapped around a fan or something, right? Well, they got it fixed up. Anyway, there's a couple of ways. Notice how those fan clutches look similar, but one of them is controlled. One of them, this is electric, and the other is mechanical. Now, If you think like a lot of people do, you're going to think mechanical is going to be better because it's easier to figure out how it works. Okay, let's move on. We're moving too slow. Okay, the engine, when the engine is cold, now incidentally 4 was true. When the engine is cold, the closed thermostat valve restricts the flow of coolant from the engine. That's actually true. When the thermostat is closed, you're not going to have any water flowing through that, or coolant flowing through that top hose.
Yep.
I was telling Chelsea the other day, and the whenever the top radiator hose gets hot and the water in the radiator is warm, you'll know everything's, the air is gone out of it and everything. Some thermostats have got a little bitty air bleed in them, so that when you fill them up with coolant, that air will all leave the block. But if that one that you were putting in didn't have that, you see what I'm saying? And so you had to wait till it opened up to let the stuff out. Now it seems to me like all of them ought to have it, All right, and most of them do nowadays for newer vehicles. The coolant that has a smaller effective temperature range but is less toxic is a 50-50 mixture of propylene glycol and water. That's true. Propylene glycol is the orange antifreeze, right? 7. I've got a chart over there, by the way. If you have that Xerox chart that you see up there, you might want to look at that. That Xerox chart is really cool. It tells you your models and which antifreeze and what color are used. But some of the European antifreeze now is purple and all kinds of other colors. It's crazy. Yeah. And I got yellow antifreeze in my truck. See that? See the yellow one? You got the orange, you got the yellow, you got the green. That's what's showing up on that chart over there when it was made. My pickup truck has got the yellow in it. And the gold, they call it.
How do you think you put everything in?
No, if you get it all out of there, don't mix it. Now they got some that'll say it'll mix with anything, but the real pundits, the engineers, don't like that. They like for you to put the antifreeze in there. It's just like what's in there. But if you're going to change one from orange to green, just flush it really, really, really good. Make sure you got everything out of it, then put the green back in there. You won't hurt anything. If you mix them, it's going to cause clogging and other kind of problems.
Why don't you start
It reacts. Yeah, they get with each other. They don't do well together. But don't pour green in there where orange was. Unless you're changing everything out. Like if you're building an engine and nothing's in the cooling system, or if you're done a really good job of flushing it. Okay, a pressure tester is a tool can be used to determine the leaks in the coolant system as well as test the pressure cap. Now, I showed Chelsea that the other day too.
That's true too.
Because of the thermostat, it looked like it was leaking from the thermostat gasket, so we pulled it off there and she cleaned it. Boy, did she work hard cleaning that thing. Got it all cleaned up and everything, put it back together just like it was, Somebody had overdone, I believe, this gasket, this 3M gasket spinning thing, probably used a green one where they were supposed to use a white one, and they overdid it, and it made a little dimple in that flat area where that gasket's supposed to seal by that thermostat, and it just had a little thing of water dripping out of there. And it didn't show up until we got the rust out that was clogging that place when we flushed it, But anyway, she put some room temperature vulcanizing rubber on it, which is RTV, which we'll look at, right? Okay, pyrometer is used to determine the freezing point of coolants.
No.
That's not right. What's it for? Exhaust temperature. Pyrometer is actually a temperature measuring thing. An infrared pyrometer is a contact type with a probe touching the surface without it being tested. False. This little temperature gun that I point at the things and it tells you the temperature, that's a pyrometer. Make sure you get a good one. Don't buy, you can get one on buy.com. It's like $12. And I bought one of those just for the fun of it. And when you first pull the trigger, it's on metric. And you got to hold it, this little button for about 7 seconds so it'll change to Fahrenheit. And furthermore, I don't think that was all that accurate. And I gave it a bad review because I said, I don't like this one. And the people that made it sent me an email, said, could you please give us a better review than that? I said, no, I don't like your product. They didn't like me giving them a bad review. Come on, man, we're trying to sell these things. You didn't tell us it's really great. I'm not going to lie about it. I just didn't like it. A relief valve that's stuck open will cause high oil pressure.
False.
That is totally false. A release valve stuck closed will cause, it can blow the oil filter flame off the car if it's stuck closed. That's high oil pressure. We got a visitor here?
Yes, sir.
Howdy.
I didn't want to interrupt you, I'm sorry.
Yeah, well,
I got a question.
sure.
I got a 2002 Dodge Dakota, you remember it?
Yeah, I think so.
I worked on it a couple times.
Yeah.
I think the oil pumps went out on it. Is that something y'all can do with it?
Oh, are you still on that? Okay. Yeah, we can probably do that. We'll have to, we're kind of swamp, so you got to do something. Is it giving you low pressure readings and clattering or what?
That's the one that me and Levi's
The gauge,
driving
the
around.
check gauge light came on the way back from Andalusia.
Come here. Okay, you guys listen to this guy's problem. Listen to this problem. Tell these guys just like you were telling me.
I was on my way back from Andalusia. My check gauge light came on my Dodge Dakota. I immediately started looking. I noticed the oil pressure had bottomed out. So I slowed down, went to pull off the side of the road. Oil pressure came back up, but it didn't come back up where it normally is. It only came up just to the first line past the low mark. So I started nursing it, trying to get it back to the house because I was right at the turn to turn back into op. Off of 84 right there by the T. So I started turning my hazard lights on, eased it. Check gauge light came back on again. I slowed back down, went to pull off the road. Oil pressure started to come back up. Eased back down the road. Check gauge light came on again. It did this back and forth. It never started knocking, tapping, anything like that. I got it to the house. Went and got the parts. Thought it was something maybe I could call a buddy of mine. Thought it might be something we could do at the house. Crawled up under there, realized where the oil pan was, and said, nope, outside my skill set.
Okay, now what we have to do with that now? That's funny that we talk about a relief valve stuck open will cause high oil pressure, and he comes in talking about a problem. Okay, I set that up, by the way. No, not really.
Okay.
A primary heat transfer device for the engine is the what?
Thermostat.
A radiator. Heat transfer.
Oh, I was
Heat
looking at that.
transfer radiator. If the thermostat sticks closed, what happens?
It'll overheat.
Yeah, and that doesn't happen as much as it used to. When I started working on cars in the early 70s, it seemed like every time we saw any problem with a thermostat, it was always stuck closed. Of course, that's the one that you notice. Everybody liked for their car to run a little cooler. But after I went to work at the dealership, it seemed like everything I saw was thermostats that would look just fine, but they would be open and way too soon. And your engine controller will throw a PO128 or a PO125 for that, because it doesn't like a cold running engine. An engine needs to run about 210 degrees. That sounds hot, but it's not. I mean, if it runs good and hot, you're going to have it running cleaner, and it's going to do better.
210 degrees.
Yeah, about 210, which is right up in the middle, real close to what you consider boiling for water. If it ain't up in the middle, if it's overlaying over, you're going to have a sludging up engine. If you're not careful, and you're not going to be efficient either. It needs to run good and hot to be efficient. Not 240, but Do you know when the coolant fan comes on a like a Chevy Cavalier? 228. 228, and I think that's ridiculously
That's
hot.
when it come on that van.
Yep.
Remember? Me and Lawrence put the transmission.
Was that pretty scary?
No.
I thought it was. All right, to test the thermostat, what do you use?
I don't know.
Oh, come on. Scan tool. Scan tool. How do you use a scan tool to test the thermostat?
Check the temperature.
Well, that sounds like a no-brainer, doesn't it? So tell me exactly how to get that happen. Everybody, these other people, none of us know how, but you do, so tell us. I'm serious.
With a scan tool?
Yeah, I'm going to take my scan tool out. How do I know the thermostat's working with a scan tool?
Well, if you're going, you got to know when the thermostat's supposed to open.
Okay.
So you plug it in, and you can actually see the numbers, how hot everything is with the scan tool.
What do I see when the thermostat opens?
Get cold.
It cools down a little bit, and then it warms back up.
Right.
Now, something else you can do, I like to look at on the front wheel drive ones, and I told her this the other day. It goes whenever your front wheel drive is, you're doing coolant system service on that, like you put a water pump on and you're putting, flush the coolant system, you're putting it back in. You want to hear that? You want to see that radiator fan? Now, turn off your air conditioner so you don't get confused. Turn your heater on, but turn your air conditioner off. When you got good hot air coming out of the register and the fan is kicking off and on, everything's working like it's supposed to. If you got a problem, that fan's going to kick on and it's going to stay on. And your temperature on your scan tool is going to keep going up, and the fan's going to keep running, and it may even kick into the higher speed. If something like that's happening, whoop, something's wrong. I'm airbound. I didn't bleed it. Now you got to know, and I got to say this before I forget it. Look in your shop manual. Some coolant systems have got a bleeder screw that you got to take out when you're filling it up. You take a little bleeder out that's kind of up high, and some of these Japanese cars that slope way down in the front so that the radiator's lower than the engine because they slope so much. There is one particular car, and I don't remember which one it is, one of the Hondas, I think. You got to jack the front of that car up so that the radiator is higher than the engine so you can get it full of coolant. If it's sitting flat on the ground, you won't be able to do it. So look at your radiator. If your radiator is lower, that's why I have.
The radiator.
Huh?
This.
Yeah.
The RX-7's got a tilt in it.
Yeah, and that's, of course, you're always engineering stuff anyway, so, all right. So anyway, so the scan tool,
Oh, I got a question. I got a
what,
question.
yeah,
What does having your radiator like this do? What will that do? I've seen a
it
bunch.
depends, it depends.
I've seen a bunch of drift cars do that.
It depends on the way that the dynamics of the front air dams and spoilers are, like the grill and all that.
Uh-huh.
Some of them actually funnel the air through there. You know, like on the Taurus, like on that Sable, it ain't hardly got no place for air to come through the front, but it actually directs the air up, you know, from underneath.
Yeah.
And so that as long as you got good strong airflow, it doesn't matter. The airflow needs to be going straight through. It don't need to go across it at an angle so that it doesn't go into it.
Right.
But if you got any louvers or anything that are directing the air to go straight through the radiator, it doesn't matter. You know how your radiator's angle, but the airflow's got to be directed through it the right way. I hope that was a good answer to your question.
Yeah.
On your scan tool, you watch it heat up, then you watch it cool down, then you watch it come up and down. Service in the cooling system may involve what?
D.
D, all of the above. Reverse flushing, bleeding, draining. The internal passages for coolant in the engine block cylinder head are critical for proper engine. They're called what?
Water jacket.
Water jackets. Now, let me tell you this. Head gaskets. You might notice in your head, you may have a hole in your head
I have one.
that looks like, very funny. They have a hole in your cylinder head that matches up with a hole in your block, and that hole may be this big. But in your head gasket, you'll have a little bitty hole like that, so that the water cannot go through there very fast. Why is that?
So keep the pressure.
No, what happens is you're wanting that water to go through that cylinder head slowly enough to where it can pick up the heat and carry it out. If you, and one time, now this was pretty spooky, anytime guys that you're doing head gaskets, and you got the head gasket, the head gasket will still pretty much be in a shape where you can see everything when you pull it off because they're really substantial the way they're made. They got the fire rings on them and all that around the cylinders and all that. But the fact is, here you are looking at the cylinder head gasket you took off of this car, and we're assuming it's the ones that came on the car. That's what I'm talking about. And you look at the new ones, you better look at them holes and make sure they're the same. All of the holes better be the same. Make sure you know which one goes on which side. They'll say up, front, this kind of thing. Some of them it don't matter. Yeah, some of them it matters more than others. But at the same time, Shannon, this one guy that was in here, he was a guy from Elba that came through here. He was pulling these, he was a careful son of a gun, and he took these head gaskets that out of the box, out there for Felpro, and he laid them on the bench next to the other one. They were shaped exactly like the other ones, except these holes were just as big on the new gaskets as the holes that were in the engine. They were stamped wrong. And he says, I don't like the looks of these. He called my attention to it. Now, some of the guys would have just popped them on there and they'd have had an overheating problem and wouldn't have known why. You see what I'm saying? I mean, it just gets hotter and hotter and hotter and you don't know why. So I called Sam, and he called Felpro, and Felpro goes, oh no, don't put those on there. They were terrified, because if their gaskets burn the engine up, technically they're responsible for the engine. You see what I'm saying? So they sent us another set of gaskets that had the little holes on your water passages, which was supposed to, which would run it cooler. But anyway, just watch those gaskets and make doggone sure the holes line up, right? Also, and I've hammered this before too, you're putting cylinder heads back on, make sure that none of the cylinder head bolt holes have got fluid of any kind in them. Because what will happen is when you screw that bolt down in there, or any other bolt hole, doesn't need to have fluid in the bottom of it, that bolt will trap that fluid. Eddie had some students down here that he had on to pull his heads off of this big V, T903 Cummins or whatever it was that he had from this truck. And it's a trainer engine that would start and run, kind of like one of ours. And they were putting it back together, and they had a bunch of fluid down in the bottom of those cylinder head bolt holes. And he had forgot to mention that, hey, you need to get your air blower, blow all them out, make sure that not a single one of those holes has got any fluid in it. And so their bolts wouldn't tighten up because it was bottoming out, hydraulic locking on that fluid that was in the bottom of the hole. You know what they did? They said, well, we'll make these suckers tighten up. They got a cheater pipe. Big, strong diesel guys like we see. They look like a mud fence, all these guys that Eddie's got down there, some of them. And they busted the block on that diesel, torquing them things. I mean, it ruined his trainer engine, and it was fluid in the bottom of the doggone bolt holes. But see, if there's fluid down in there, you're thinking, don't worry about it, it's just a bolt hole, this is all metal, it'll be aight. make darn sure you blow every one of them holes out. And I tell you what I like to do too sometimes, if I'm really a stickler, I'll run a tap down in those threads, the right size tap to clean them out. Blow that out, make it pretty and clean, and put a little lubricant of some kind. Yeah, well, anti-seize ain't what I'm talking about, like motor oil usually. Now, sometimes they'll tell you in your book, don't lubricate the threads. Sometimes they tell you to lubricate them, sometimes they don't. How many of you guys know what a torque to yield bolt is?
A what?
Torque to yield.
I don't understand it.
I can tell you, you're going to understand it in 2 minutes. You'll understand it. You ever heard of that?
I've
All
heard
right.
it.
Ordinarily, when you're putting a cylinder head back on, you pull your torque wrench around until it clicks, right?
Mhm.
All right. Well, on these torque to yield bolts, you pull it to a certain foot poundage, and then you go 90 degrees, and you go another 90 degrees. Now, what's that doing? That's stretching the bolt. The bolt is actually stretching. If you got torque to yield bolts, in other words, if you look at the torque specs and it says tighten it to 44 foot-pounds to go 90 degrees on all of them, following the pattern, another 90 degrees following the pattern, you better put some doggone bolts in there, new bolts, because you're not supposed to reuse torque to yield bolts.
Yeah.
And these 5.3 in this GMC out here has got torque to yield bolts in it. They're like that long. It's got, well, actually, it's got three different. It's got some 8mm bolts, and then it's got some bigger bolts. It's real coarse threaded. I got some out here to show you. But those bolts are extremely important. Do I have some in the store here? I don't think so. Anyway, I got some out here I can show you. But those are torque to yield bolts. Huh?
You can look at a bolt and see how stretched it is.
Yeah, but the thing about it is, it's not going to stretch and stay stretched. It's going to unstretch, but it's not going to be as strong the second time around. And you're subject to have it go pop, or pop later.
Yeah.
And say something else had happened. When this is an hydraulic lock thing. Did a Toyota Camry in here. Had to pull the head off, put it back on, and had some fluid in that bolt hole. Right over here on the back corner of the back passenger side corner of the engine. And the guy that did it, when he torqued them down, there was enough fluid in there to where it began to shear the threads on that bolt. I mean on the block, not the bolt, but the block was aluminum. All right. 9 months later, the car developed a really, really bad oil leak. So it comes back in here and it's leaking from that corner of the cylinder head. Because what's happened is those threads have finally given way, and you've got and when we pulled the bolt out of there, what came out with it was what looked like a little spring.
Little helical.
Yeah, well, except it was aluminum. The threads had sheared the rest of the way off, and you couldn't tighten them up. So we actually had to helicoil that doggone hole. It's either that or buy another engine. You know what I'm saying? And I actually had to drill with a 5/8 drill bit down in there. And what was really aggravating about that, I've got this big old DeWalt drill. I'm drilling real careful with my 5/8 drill bit down in the engine block, holding it like this. And that DeWalt drill was so strong. A 5/8 drill bit's big around as your thumb.
Mm-hmm.
And I'm drilling down through there, and I got down to right down there where we needed to be, and that drill caught, and it broke that 5/8 drill bit. Popped it off. Of course, I was able to work it out of there. It ain't like a broke. Well, it was only caught on the very tip. There's a guy named Philip Kirkland that was working with me over there. Well, he was working in the next stall. Me and he and I were both commissioned technicians and all. And he had to drill out a bolt that was in the end of a cylinder head on a Grand Wagoneer back when Jeep had them old V8 engine J series truck.
Yeah.
And he was drilling up in there. And he was usually a pretty laid back kind of guy. He was a good mechanic. He could fix just about anything. But he's drilling up in there with a drill right there at the corner of the head. Because see, it came in for this. This broke off. We need y'all to drill this out. So at some places, they hire somebody to come in and drill out bolts. I ain't never worked at a dealership where they did that, but at some dealerships they do. Drill up in there, and his drill bit goes pop, it broke off. And he was waving his hands around, running around in a circle. Oh no, I don't know what I'm going to do. And I said, listen, think about what you're talking about now. The drill bit is caught right on the very tip where it's cutting, right on the very tip. I said, if you take an air hammer and you stick it against the block, the head right there where by where the bolt is, and you pull the trigger real slowly so it goes it's going to create vibrations, and you'll probably see that drill bit loosen up and it'll fall out of there.
I never thought of that.
Just try that. And so he did that, and the drill bit came loose and fell out. And he was like that. Well, this guy right here, he was panicked, because it was breaking. Brandon, he wouldn't worry about it. Brandon would walk away, let somebody else fix it, You can't do this. But what happens is, if the boss man comes to you and says, you've got to fix that, and you're not going to get paid for anything else until you do. You know what I'm saying? That's how that thing goes. Okay. But anyway, that doesn't happen a lot. But there is a price to pay if you're a yo-yo. Okay.
Never thought about using air hammer.
Yeah, air hammer is cool stuff. My dad taught me how to use air hammer all kinds of ways.
And you told me all kind of ways, and I've been.
Boy, it was astonishing to me. My dad would put an air hammer against the end of a shaft that had a bearing on it, and he'd just go, brrr, and that bearing would just walk off of that shaft. You know, just right by itself. It just walked, but there's no reason for it to be moving. It would just move right off there. And I was thinking, how did he know this would happen? You know, I mean, I was just like a young teenager at the time. But anyway, let's see, that's about it, isn't it?
Drive train test one, and special topic.
That's all. We're not going to do those other tests right now, but that's just been a. Oh, well, let me finish up by telling you about this guy that I was telling you about earlier. He was.